Good morning, everybody. I'm back again with your notes for today. The first thing that you should know is that your homework key from yesterday was posted. It should be the first attachment on your Google Classroom. That was for the assignment that I believe was 8 to 30 even. So please check your answers. Please work them out together if you do have any questions. Okay, today we're going to start day 2 of this section. So we're going to talk about the inverse of a function. First thing I need to tell you is for my functions, I'm going to be using f and g to name my functions. Okay. First things first. Number 1, in an inverse. Okay, so in the inverse, basically x and y are switched. So in f, if I have x comma y, in g, it'll be y comma x. This is saying the domain as f is the same as the range for g, and the domain of g is the range of f. So basically they're flip-flopped. We also can do compositions. Now, remember from Algebra 2 what a composition is. F of g, remember the little circle symbol means composition. And if you do that, you should get x. Also, if you do g of f, you should get x. Now, if you happen to not remember what those compositions are, don't worry. I will show you here in a little bit. But for both of those, you should just boil down to an x when you're all said and done. Now, this book likes to use a little bit of different notation. So sometimes, instead of saying f and g, they'll say f of x and f to the negative 1 of x. Those mean inverses. The negative 1 symbol is the little inverse indicator. So if I'm going to do compositions, that would be the first way. And that would be the second way. And remember, these things both must equal x. Okay, so let's go ahead and let's try some of these using these compositions. So if I give you two functions, you need to figure out whether or not they're inverses. So in order to do that, we're going to do the composition. Now remember what composition means. It means you're going to take the g function and you're going to insert it into the f function. So I'm going to take this g function right here and I'm going to insert it into the f function right where that x is. And it will look something like this. Everything else about that f function stays the same. I'm just putting the g function in where that x is. So now we'll simplify this a little bit. And that's what I come down with. Now, if you remember back in my definition, I said that it had to boil down to just an x. Well, it doesn't. So I could basically stop right here and just say no. This thing will not be an inverse. There's no reason to even check the other one. But because I want you guys to have the practice, we're going to go ahead and check the other way as well. So this means I'm going to take the f function and now put it into the g function. So I'm going to take this f function and I'm going to put it into the g function. And it will look something like this. Notice I only put the f function in where the x is in the g function. Okay, so let's go ahead and distribute this too. And you'll notice, again, it doesn't boil down to just an x. They both have to equal just x in order for them to be inverses of each other. Let's try another one. So I'm going to take the n function and I'm going to put it into the n function. The n function and put it into the m function. So it'll look something like this. Okay, so now I'm going to have to get common denominators down there in the bottom. My common denominator will be x. So the first one is good. The second one needs multiplied. Now I can put them together. Looks like that. If I multiply by the reciprocal, it looks like that. The 5's will cancel, and I come down to just an x. That's good. That's what I want. But now I need to check the other one. Go the other way. I'm going to take this m function and put it into the n function. So I'm going to take this, and I'm going to plug it in both places for the x. So you can see this is going to get a little bit complicated here. So there's my numerator. And there's my denominator. Okay, so if I multiply that by 2, I get that. Now I'm going to need to get common denominators. So x minus 2 will be my common denominator. Looks like that. If I distribute, looks like I'm running out of room here. If I distribute that 5 and combine my like terms, basically I get, whoops, that. If you multiply by the reciprocal, you will notice all of that cancels, and I'm just left with x. So since they both came all the way down to just an x, they are inverses. So the final answer after all that work is just a measly little yes. Okay, let's try another one of these. Take the g function, put it into the f function. Distribute, combine, and that looks great. Let's go the other way now. Take the f function, put it into the g function. So, yes, these things are inverses. They both boil down to just an x. All right, let's do one more of these, and then we'll move on to something else. Take the v function, put it into the t function. Gonna have to get common denominators, which will be x. Combine them. Multiply by the reciprocal. So far, so good. Again, make sure you pause this if you need to catch up here. All right, now we're going to take the t function and put it into the v function. A little bit more complicated. Going to need a common denominator in the numerator, which will be x minus 1. Looks something like that. Distribute, combine your like terms. Looks like I'll just end up with that up top. Multiply by the reciprocal. And everything will cancel except for that x. So yes, these two functions are inverses of each other. Okay, so I gave you two functions and asked you to determine if they were inverses or not. Now I'm going to give you the function and ask you to find me the inverse. Well, in the inverse, we talked about how the x and the y are interchangeable. You know that f of x is the same thing as y. So if I'm going to find the inverse, I need to interchange them, which means it looks something like that. And once I interchange them, I'm now going to solve for y to get my new function. So it looks like my new function looks like that. Now we're going to make sure we write this in the proper notation though, using that little -1. So this would be the final answer that I would expect out of you. Okay, let's go up here and let's try again. I know that, but now I need to interchange the x and the y. And now I need to solve for y. So I'm going to move the y minus 3 over. I'm going to distribute it. I'm going to get everything with a y to this side, everything without a y to that side. Now we're going to take out that y and isolate it. So it's looking like, oops, I forgot to distribute way back here. Back up the bus here. There should be an x on here. So now we're in business. It looks like that. Of course, you should try and reduce if you can, but you cannot reduce, I don't believe here. Let's see. Still think I got some kind of error going on here. Nope, maybe not. I think it's all good. So if I'm going to write my final answer, it's going to look like this. Okay. All right, getting a little bit more complicated here. So if I want to isolate that y, I got to get the cube root off of there, which looks like that. And really, this is pretty easy here. And there we are. All right, let's do 2 more and we'll call it a day. And last but not least, all right, folks, that is our first day on inverses. Again, remember, we're just flipping the x's and the y's. Here's your homework. Feel free to work together. Talk about it if you need to. And I will have your key posted tomorrow. Have a good day.